Hello everyone. In this video we will work group work problem number 2 from lecture 6, the KVL KCL lecture. And in this problem we are asked two things. First, to write the expression for KVL on the circuit given, and then in part B to compute the current value I. And what do we have here? We have excuse me, one loop. We have several voltage sources in the loop. We have several resistors in the loop, and we have current I given. Now, if you recall from lecture, so KVL tells us that for a loop, the sum of all voltages around that loop must be equal to 0. And the other thing we can remember is we have good old Ohm's law that we can say if we have resistor R and some voltage drop V, current flows from positive to negative on a resistor. Okay. We also know the conversion here that 1 kilo ohm is equal to 1,000 ohms. Okay. So we can do our conversions. Now, when we also go back here, the sum around there, what are the other rules there? We also have that we go around in a clockwise fashion. So we want to loop clockwise, and that if we hit a positive first, then we use a positive designation in our addition. If we hit a negative sign first, or we have a voltage rise, we get a negative. So to solve this problem, how I would approach it is the first thing is I see my current direction here, and I can now use Ohm's law to label it. So from there, so I'd have positive minus, current keeps going in this loop this way, so positive minus, right? So you still have current's going to come around here, so you'd have positive minus, and it's going to come around here, positive minus, right? And we could label each of these as V1, V2, V3, V4, but since we know that V is equal to IR, we can also substitute in, right? Which we did in problem 1. So now we can simply go around the loop and write up our additions. So I again like to start in this corner. So if this is loop A, we can say for loop A, right, we start here, we first go up, we hit negatives, so we say minus 10 volts, go here positive, so we go plus I times 2 kilo ohms. Right, just the voltage drop across this resistor. Here we have negative first, minus 3 volts, minus here, minus 9 volts. We hit this one, so plus I times 500 ohms, plus here I times 5,000 ohms, or 5 kilo ohms, I times 5 kilo ohms. Then come around here, then we say plus 2 volts, right, because we hit a plus first. Then minus 5 volts, and finally plus I times 10 kilo ohms, and we come back there, so that's going to all be equal to 0. Okay, so here is our KVL expression for that loop. Now, and that's really part A then, right? If we write our answers at the bottom. Now, for part B, go ahead and determine the value for the current I. So all we're going to do here then is we're going to sum up our voltages on the equation, and then we can start summing up our currents, right? So we can go here. So if we kind of refactor this equation, so we can go over here and go minus 10 volts, minus 3 volts, minus 9 volts, plus 2 volts, minus 5 volts, right? So that pulls out 1, 2, 3, 4, 5, and that's going to be plus I, right? And all pluses there, times 2 kilo ohms plus 500 ohms plus 5 kilo ohms plus 10 kilo ohms, and that's all going to be equal to 0. I'll just put it over on this side because I ran out of room there. But so what we've done here is just rearrange this equation to start adding it up. Okay, so here we say, okay, minus 13 minus 22, 20, minus 25. So you get that minus 25 volts plus I times, and now we can add these up here. Now if we do our unit conversions, of course 2 kilo ohms becomes 2000. So we get 2000 plus 500 plus 5000 plus 10,000 ohms, right? And that's going to be equal to 0. That was a little bit bad. I have to really go in. That would really show my unit conversions here if we were asked to do so. But you get that. So now we can go at minus 25 volts plus I times, we can add this up. So 5,000, 15,000, 17,000, 17,500 ohms. That's going to be equal to 0. Okay. And we want to solve for I, so let's rearrange here to get I by itself. So we can add plus 25 volts plus 25 volts. This is that I times 17,500 ohms is equal to 25 volts. Now we can divide through by 17,500 ohms on both sides. And we get that I is equal to 25 volts divided by 17,500 ohms, which is equal to amps. Right, so we could say here 25 divided by 17,500 amps will be the value of current. And of course you can plug that in and get a decimal value if you like, but leave it with you there. So this is the second problem, again, where we're first writing our relation down, where simply what you want to do is just go around the loop, following your signs very carefully, and make sure you sum that all up to 0. And then once you do that, it's as simple as just factoring the different aspects out, so you can combine them and then ultimately arrive at your result. So I hope this was helpful. Feel free to comment below and like, and look forward to another video.